In this topic of manometry, we would like to cover the instruments that we utilize to measure the pressure. The manometers are different type of manometer exist. They utilize to measure the pressure or a difference of pressure between two reference points. So one of the type is called or is known as the simple manometer, in which you have a column tube inverted vertical, and the fluid here is mercury. So by measuring this difference of height, you can easily utilize the hydrostatic equation to measure the pressure. Similarly, this is a U-tube manometer, so in which the working fluid is mercury, and this is connected to a pipe. It has some different type of fluids. So because of the pressure of that fluid, the level of this mercury changes, and again with the help of the measurement of this height, you can easily utilize the hydrostatic equation to measure the pressure, difference of pressure. Now, how did we have obtained the hydrostatic equation for difference of pressure? Recall from the differential equation of pressure, hydrostatic pressure, that we have obtained earlier. That was our equation, and for constant value of density, it can be integrated between two reference heights. So once I go and perform this integration and substitution of these limits, I will get an equation like this, which is providing me the difference of pressure between 2 points, point 1 and point 2. So make sure that your reference points, point 2 is always the upper point. So point 2 is always higher than point 1. Now next, I would like to mention the concept of gauge pressure. So gauge pressure is nothing but a difference of absolute and atmospheric pressure. So this is my absolute pressure, which is reference to absolute pressure, reference to vacuum. So here I would like to give the example of absolute pressure. So for example, I have a room in which the pressure is maintained at a higher value, higher than the atmospheric level. This level is my level of pressure, and with some mechanism I go and start reducing the pressure. So once the pressure start reducing, it will reach to a value at which the pressure will become atmospheric pressure, and further reduction in this value will go to the vacuum. So at this vacuum, the pressure is zero. Zero pressure. So that's how I go and relate my absolute pressure. Is that absolute pressure is total of the gauge pressure and the atmospheric pressure.